Hello my dear students, welcome back to NEET World. So today we will be discussing the PYQs of thermodynamics. So from JEE, NEET and EAPCET entrance exams and related questions we will be discussing from thermodynamics chapter. Okay, yes. So if you are already studied this topic, yes, it's well and good, just practice some questions. If not, okay, just follow our like YouTube channel where we have covered thermodynamics important topics. You can watch them, and also now you can focus here in this discussion. Now I will be giving this, see, on thermodynamics I will be doing 2 sessions. Okay, important questions like previous year question, must do questions from thermodynamics. I am going to do 2 sessions. This is our first session where I am going to give you some basic questions first, so that you will get some confidence from about this chapter. Okay, now so let us begin this. See what we are discussing in thermodynamics. See, in thermodynamics, thermo means what? Heat. Dynamics means what? Movement. So movement of heat during the chemical reactions, how these energies are changes, like when reactant is converting into product, whether heat is absorbed by the reaction or released by the reaction. If it is released or absorbed, how much amount it is absorbed or how much amount it is released. So this kind of things we are going to study in this thermodynamics chapter. I hope you know these things. Yeah. So next, let us start our first question here. Look at here what they are saying. Under isothermal condition, see, this is a NEET 2019 question. So what it is saying, under isothermal condition, it means isothermal means temperature constant. Okay, a gas at 300 Kelvin expands from 0.1 liter to 0.25 against constant external pressure of 2 bar. The work done by the gas is, so just take what is the work done formula. So work done, PV work done formula, we have P and V, right, change in V. So what I can say here, so PV work done formula I can use. So my W equals to minus P external dV, right? Now this is a formula we can use here. So minus, okay, what is the pressure they are saying, 2 bar into what is change in volume. So check here, volume changes from final V2 minus V1, that is 0.25 minus 0.1 liter. Okay, so what we are going to get here, see, it will be minus 2 into 0.15 liter bar right now. Yes, so but there is no option in liter bar. See, they have given a data, see, 1 liter bar equals to 100 joules. So you can write minus 2 into, so 2, this I can write minus 0.30 into this liter bar, I can write 100 joules right now. So that we are going to get minus 30 joules. Right now this will be your answer for this particular question. How easy it is? Yes. So what is our option for this? Our first answer will be perfectly correct for this particular question. Hope this is clear, right? Yes, if it is clear, just click on the like button, right? Yeah. So now I will be giving you one more question. I will be giving you one homework question based on this particular topic. See, work done in an isothermal process at a temperature of 27 degrees Celsius when 2 mole of ideal gas expands from 1 liter to 10 liter. Okay, very easy. What is the equation you have to use here? Tell me whether it is work done by the system or work done on the system. See, expands. See, volume is expanded from 1 liter to 10 liter. It means volume increased. So I can say expansion. Okay, so expansion work is what? Work done by the system. Okay, what is the formula here you can use? From the given volumes and number of moles. So just use this. Work done is equals to minus 2.303 nRT log V2 by V1. This is the integral equation we will get. Okay, so integral equation of this thing. okay, this is differential, this is integral, okay. So using this you can able to solve this question, okay. Yeah, generally you can see questions from isothermal process either from this one, from this formula or this formula based questions. Oh, these are two important models you can remember, okay. Yes, let us move forward, okay. Here we have one more question. So this is from first law of thermodynamics, very easy. Look at here, a system does 100 joules of work, okay, on surroundings by absorbing 150 joules of heat. Calculate change in internal energy. So how you are going to do this? Calculate change in internal energy. See, what is the first law of thermodynamics equation, mathematical equation? Delta U, change in internal energy, equals to heat plus work done, so W, like this, okay. So now what they are saying here, to the system, see, if this is a system, try to understand this, the terms or the symbols are very important, signs are very important here. See, system does 100 joules, from this system work is released, I mean work done by the system, so it means W should be negative, that value should be taken as minus 100 joules, like this you take. And on the surroundings by absorbing, see, it is absorbed by the system, see, Q, heat is absorbed by the system, it means positive it should be. So positive, absorbed means positive, released or doing some work by the system means negative, okay. So if heat released means that should be negative, heat absorbed now positive, like that you should take. So how much it is? 150, right, that's it, very simple here, but taking these signs are very important here. So what you are going to get here, plus 50 joules, okay. So question will be easy, formula is also easy, but taking this proper signs, understanding the question properly is very important here, okay. So your option number 2 will be perfectly correct for this question, right. Yeah, very simple and easy questions, right. Yeah, okay. Yeah, next. So look at here, the statement based question here we have, out of the following the correct statement is, so W, work is a state function they are saying, no, work is a path function, work is a path function, it depends upon how you are doing, what is the path followed during the process. So in order to go from here to here by carrying something, let us say that is a work, so we can go like directly like this or something like this right now. So from initial state to final state. So now this work depends upon what? Path followed, okay. So it is a path function, it is not a state function, so this is incorrect. So next, delta E is equals to Q they are saying. So delta E equals to Q, so this will be the scenario, the internal energy change will be equals to heat, that will be the scenario in case of isochoric process, okay. So why I am saying in case of isochoric process, what we have first law of thermodynamics, dE equals to dQ plus dW I am writing, okay. So now isochoric process means what? V constant, right. So V constant, it means dV, change in V will be 0 right now. So now dW means what? dW equals to minus PdV, okay. So P into dV, dV is how much? 0, so put 0, so dW becomes 0, so this will be 0. So now what I can say? dE equals to dQ, okay. This will be the scenario in which case? In case of volume constant right now. So this is isochoric, this is isochoric process, but they are saying isobaric. So in case of isobaric process, QV, isobaric means pressure constant, so QP will be equals to enthalpy change, delta H. So dH equals to dQP you should say, okay. I hope this is clear. So it means the whatever the statement they mentioned, it is also incorrect here. So this will be the scenario in case of isochoric, not isobaric, okay. Next, so here delta E, next here we have Q equals to 0 for every cyclic process, no, see. So remember, Q and W, these are what? Path functions right now. So these are path functions, okay. Q may or may not be equals to 0 for path function in a cyclic process, but for all state functions in a cyclic process, operating in a cyclic process will be 0, change will be 0. So this is also incorrect. Next here we have, see, delta E is a state function. What is this? It is a state function. So for state function, change in cyclic process will be, the net change in cyclic process will be 0. So this will be the perfectly correct statement. Okay. So now you need to remember what are state functions and what are path functions. Okay. So in case of state functions, they depends only on initial and final state of the system, but not how this path followed during the achievement of the final stage from this initial state. Okay. So what we can say, state functions are independent of path followed, path functions follows path followed by the system during the process. Okay. So now what are the examples for state functions? We have like pressure, temperature, volume, okay, internal energy, enthalpy, okay, Gibbs free energy, all these things comes under what? Entropy, all these things comes under state functions. Okay, state functions. They will ask which of the following is a state function. Now path functions, you remember heat and work. Okay, these are the example you can remember. Now here I have one more question. Okay, so delta E is equals to 0 in which process? As like above question, I have one more question as a homework. Tell me. So just give a try from your side. Already explained everything in previous question. Use that concept to answer this question. So tell me, energy change, internal energy change is 0 for which process? Which process it is? See, if it is a cyclic process, yes, we can expect, and isobaric process, no. Okay, isochoric process, what it is equals to? dE equals to dQ, so it is also not 0 here. Adiabatic process, not 0. Okay, so it means only option number 1 will be your perfectly correct answer for this question, because change in internal energy is 0 in a cyclic process because it is a state function. Okay, yes. So why in a state function, why it will be 0? See, if I am doing a process in cyclic manner, for example, I am doing in this cyclic manner. So now what I am saying, state functions depends only on initial and final stage. Right now, see, initial and final stages are this one only now. See, it starts from A, goes to B, goes to C, goes to D, again back coming to the initial position only. Final and initial states are same now for this particular cyclic process. So it means change in final and initial, like A minus A will be 0 only now. So that's why the state function change in a cyclic process will be 0. So I can say if Z is a state function, so change in state function in the cyclic process will be 0. Remember this as a mnemonic or whatever the way you can. Okay, yeah, this is an important point, should be remembered. Hope this is clear. Yeah, next. Okay, so out of the following statement, you need to answer which are state functions, which are path functions here. So W is a state function. No, just now I told you Q and W are what? Q and W are path functions. Okay, yeah, we discussed these two questions already in the previous page only. Yeah, so now here we have one more question. So can you try this question? I want answer for this particular question. A system is provided with 50 joules of heat. Okay, a system is provided with 50 joules of heat and work done on the system is 10 joules. Okay, the change in internal energy during the process. So they are saying delta U. Okay, so delta U is equals to Q plus dQ plus dW, let us write. Okay, so what is the Q they are saying? System is provided with 50 joules. Okay, so system is provided with 50 joules. So you are adding 50 joules of heat to the system, right? And work done on the system. So work done on the system now, this is also positive, 10 joules. So total how much? It should be plus 60 joules. So this will be your answer. So what is your answer? A system is provided with 50 joules heat and 10 joules of work done on the system. So change in internal energy will be plus 60. So where do we have? Here option number 2 will be your perfect answer for this question. Hope it is also clear, right? Let us move forward with one more question here. Yeah, see, the question says, among the following statements, the set of parameters that represent path functions are. So path functions, what I told you, work and heat are path functions. Okay, and next what about this Q plus W? So du equals to Q plus W. So Q plus W, I can say this is du only, change in internal energy. Change in internal energy is a state function. This is a state function. And H minus Ts is given now. This H minus Ts is what? This is G, Gibbs free energy. Okay, Gibbs free energy also change for state function. Okay, all free energies are state functions here. Remember this statement. Okay, yeah. So now what are the path functions here? B and C. So your option number 2 will be perfectly correct for this question. Yeah. So here we have one numerical type or some small question. Just look at here, very like we are seeing some questions in the exam related to this kind. See, I will give you one basic idea. See what they are saying, the difference between delta H and delta U. When combustion of 1 mole of heptane, what is the formula of heptane? Very easy, look at here, heptane C7H2N plus 2, it means C7H16 na. So because CnH2n plus 2 is a formula of alkanes, general formula of alkane. Heptane means 7, so 7 to the 14 plus 2 16. So that's why I am taking heptane formula like this. This is in liquid in state, right, mentioned. Okay, now combustion, on complete combustion, okay, 1 mole only, 1 mole of heptane only, okay, gives 7 moles of CO2 because all carbons will be converted into CO2. CO2 is a gas, and along with this water formation takes place. So now how many water molecules here? 16 are there now. So you should take here 8, therefore 8 to the 16 hydrogens are over, like that. Okay, so hydrogens are balanced, carbons are balanced. Now what are the other things to be balanced here? Oxygens. So how many oxygens are there here? So 7 to the 14 plus 8. So how many it is? 22. So 22 oxygens this side. So 11 into 2, 22 oxygen this side, right? So this is how you need to balance the equation first. After balancing, now look at here. So this is a liquid. Oxygen will be in gaseous state first, right? Write it like that. So CO2 gas and H2O will be in liquid state, normally at room temperature consider. Okay. So now what is the relation between delta H and delta U? See, we have enthalpy delta H equals to delta U plus delta NGRT. What is this delta Ng here? So number of gaseous products minus number of gaseous reactants. So I am writing delta Ng equals to, what are the gaseous products here? So only 7 CO2 molecules are gas and water is in liquid. So consider only gases. So summation of NP, number of gaseous products, minus summation of NR, which are in gaseous state. Consider only in gaseous state. Okay. So what is your answer for this? See here 7 minus, here how many are there? 7, and this is liquid, don't consider this, this is gas. 7 minus 11. So it will be how much? Minus 4. That's it. So delta H is equals to delta U minus 4 RT should be your answer for this question. Hope this is clear, right? Yeah. So what is our option for this? Delta H equals to delta U minus RT. Now they are asking the difference right now. So difference means delta H minus delta U is equals to minus 4 RT. That's it. This is simple, very easy, right? So minus 4 RT will be your answer. Hope this is clear, right? Move forward with one more question here. See, the enthalpy change for a reaction, the given reaction is there. So for that they mentioned delta H is equals to minus 92.38 kilojoules. Okay. So temperature is 298 Kelvin. Okay. So now what is delta U? So just now, based on the previous discussion, you can able to solve this question. How can you able to solve this? Delta H equals to delta U plus delta Ng RT, right now. So but here I want delta U. So you can write delta U is equals to delta H minus delta Ng RT, right? Yeah. So now what you are going to get here? Delta U is equals to delta H is how much? So minus 92.38 kilojoule, okay, mentioned. Delta H is mentioned. Enthalpy change is this much for this reaction. Minus, what is delta Ng here in this reaction? See, one gaseous reactant, another gaseous reactants are 3 moles and these are gaseous product. So gaseous product are 2 minus gaseous reactants are 3 plus 1, 4. So 4. This will be minus 2. So take here minus 2 delta Ng is into RT. So what is that RT here? Delta Ng. So what you should take here? See, delta H minus and delta Ng is minus 2 into RT. So this value is given in kilojoules now, your R should be also in kilojoules. R is equals to how much it is? 8.314 joule Kelvin inverse mole inverse. So kilojoules means 10 power minus 3 kilojoule per mole per Kelvin, like this you should take. Okay, so into 8.314 into 10 power minus 3 into temperature is how much? 298. So 298 Kelvin. Okay, like this. So you have to take like this and try to simplify that. So try to simplify that. Okay, so by simplifying this, so here minus 92.38, so this will be minus, this will be plus. So here 2 into 8.314 into 0.29 I can write. So by doing this, so you are going to get minus 87.42 kilojoule will be your answer for this particular question. Okay, hope it is also clear. Yeah, so these are the steps. What is the first primary thing you should remember? What is the relation between delta H and delta U? That's it. After doing that, finding delta Ng properly and substituting here. That's it. 2 steps only. Okay, yeah, simple. Yeah, next let us move forward. So try to do this. So how can you approach this question? Tell me, anyone in the chat box. So look at here, 5 moles of an ideal gas, Cp is given this much, is heated from 27 degrees to 87 degrees. So what is enthalpy change? See, enthalpy change is equals to delta H equals to Ncp dt. This is a relation between Cp and delta H, okay, or dH also you can say. Okay, now they are asking this dH or delta H is equals to N. How many moles it is? 5 moles. Put here. And what is the Cp mentioned? 7/2 R. That's it. Okay, R. So R, all the answers are in calories here. So you can take R equals to, R means 2 calorie per Kelvin per mole you can take. Yeah, like this. Next, dt is how much? So dt mentioned, change in temperature is how much? Final minus initial, 87 minus 27 will be how much? 60, right now? So 60 here, that's it. Okay, so what is your answer here? So what is your answer here? So N is 5, Cp is 7/2, R means 2 calorie per Kelvin per mole I am taking, and difference in temperature is 87 minus 27, like this. So this will be removed. Okay, so next, so here 42, 5 into 40 to 420 calorie. See here per Kelvin is there, Kelvin is removed. So here also mole is there, mole removed. So we are remaining with calorie. Okay, 0, 0, 1, 21 calorie. So your answer is 2100 calories. So first option will be your perfect answer. Second option will be your perfect answer. See, first option they given in terms of joules, but our answer is in terms of calorie. So second option will be your perfect answer for this question, right? Hope this is clear, right? Yeah. So now same question they will also ask for delta U. So how do you do this delta U for this gas? So simple, they given Cp now. So now we have Cp minus Cv equals to R, right now for 1 mole. Okay, so now here Cv will be R, like just send this that side. So Cv will be how much? Cp minus R. So this is 7/2 R minus R, 7/2 R minus 7/2 R minus R. So this will be how much? 5/2 R. So this will be the Cv value. So now you can find delta U is equals to Ncv dt. So in this way you can able to calculate even delta U also for the same question. Okay, yes. Okay, next let us move forward with few more questions here. Yeah, look at here, 1 mole of an ideal gas at 300 Kelvin is expanded isothermally from an initial volume of 1 liter to 10 liters. Okay, so given R value in calories, they are asking us to find delta I. See, whenever you see a question, do not go directly to taking some XYZ formulas and substituting. Just read the question properly and be conscious while doing this kind of question. See, because they are saying here isothermal process and asking us to calculate internal energy change. See, we know from first law of thermodynamics, internal energy dE is equals to dQ plus dW, right now, right. So here isothermal means temperature constant, right. So T constant, okay. So change in temperature will be dt will be 0. If T constant, dt will be 0 here. So from average kinetic energy formula, what we have? So energy will be proportional to temperature. If temperature increases, energy also increases. But here temperature is being constant, so energy also be constant, right? Internal energy also be constant. Therefore, change in internal energy will becomes 0 here. If temperature is constant, its change will be 0. If internal energy is also constant, then its change will be 0. So internal energy in isothermal process will be, change in internal energy in isothermal process will be 0. So this should be your answer. No calculation, nothing. Just look at the question properly and what they are asking, and you can take this answer as your answer. Okay. Now one more thing here, if the same question is given, now if they ask for work done, what you are going to do? I already given this model question. So W equals to how much? Use this formula if they ask for work done. So you just use this formula, minus 2.303 nRT log V2 by V1. Okay. Yeah. So because volumes are given, initial final volume, expansion is taking place. So use this formula, you are going to get an answer for this particular question for work done. Okay, they are asking for internal energy, so for this second option will be your perfect answer. Okay. Yeah, let us move forward with few more questions here. One more model question, same, even this is a JEE mains PYQ. Okay, so calculate the work done during the process when 1 mole of ideal gas allowed to expand freely into vacuum. See, into vacuum means, what about pressure? Like vacuum means what is the external pressure? 0, right? So work done formula we have minus P external dV right now. So this is change in the volume of system right now, and this is external pressure, but externally vacuum it is now. If this is the system now placed in a vacuum, let us say this is a vacuum here. So vacuum means here pressure will be, P external will be 0. If this P external is 0, 0 into something will be 0. So work done will be 0 in this case. Okay, these are very like logical or just basic understanding. They may check by giving the two questions which I am showing here now and previous question. Okay, very easy these are. Yes, next. So in the next session, whenever I am going to come with thermodynamics, we will be doing purely very like very good questions. I mean, these are very basic, right? So I hope you got some basic idea on thermodynamics. I mean questions like basic questions. Okay, so now we can continue the thermodynamics sessions in the upcoming sessions also. So discussion on thermodynamics. So just stay connected with this channel so that you will get complete idea how to solve the questions from different exams, from different chapters. Okay, and look at here, 2 moles of an ideal gas, monoatomic ideal gas allowed to expand adiabatically reversibly, okay, from 300 to 200 Kelvin. What is the work done? So they are saying work done here. So how can you do this? Again, see, we have first law of thermodynamics. What is that? Du equals to dq plus dw we can write. But this is an adiabatic process now. So in adiabatic process, no exchange of heat. So Q is constant. So dq will be 0 right now. So this term will be 0. So that du equals to dw. So whatever the work done, that is by utilizing the internal energy of the system. Therefore what happens, if work is done by the system, it means some work is done by the system. System is doing work, on the surroundings. So therefore that is done by using its internal energy. So by using its internal energy, okay, so the internal energy of system decreases, therefore temperature decreases, therefore I can say during adiabatic expansion cooling takes place. What happens? Cooling takes place in the system. Okay, right. Now what is this question they are asking? We need to find a work done. So we have, what is the relation between du and Cv? So du equals to Cv dt we have now. So for 2 moles like NCV dt we have, okay. So dW equals to du, which is equals to NCV dt. That's it. This will be your like formula to be used here. So N is 2 moles and here what is this? 12.5, okay, kilo like joule per Kelvin per mole is given into dt. So dt is how much? 300. Final temperature 300, initial temperature like okay, initial temperature this one, initial T1, this is final T2. Okay, that is what expansion. What happens? Cooling takes place, I mentioned na. It means final temperature will be, initial temperature will be more, final temperature will be less. Okay, T1 equals to 300, T2 is equals to 200. So what happens to this dt? dt will be T2 minus T1. It means what? T2 is 200 minus 300. So this will be minus 100. Okay, so to substitute here dt value minus 100. Hope this is clear why I am doing separately, just to make you clear with what is this dt value. Okay, put here so that you are going to get a dW as minus, see this will be 25 into 00 joules this is. Okay, so we got our answer in joules, but they are asking in kilojoules. Okay, you can multiply, you can divide with 1000, so that 2.15 kilojoule will be your answer. Okay, minus 2.15. See, the negative sign here is very important, because see there are negative and positive values also sometimes. Okay, so how this negative sign got here? From dt. Okay, so work done by the system, see they are saying expansion. So expansion means that is work done by the system. It should be negative terms. Minus indicates what? Work done by the system. So your answer should be minus 2.15 kilojoule per kilojoule. Okay, hope this is clear. Right, if everything is clear from our discussion, yes, Aman, you can ask your doubt in the chat box. I am free here to explain your doubt. Yeah, if everything is clear, I am going to give you 1 or 2 questions as homework. Yeah, so look at this question. So take this question as a homework, which I am going to discuss in upcoming sessions. So take the screenshot of this and give a try, and you can do this one also based on bond dissociation energies. Okay, and this one also, all these 3 questions as homework, which we are going to discuss in the upcoming sessions. So thank you for watching. Stay connected with this NEET World channel, and if you are new to our channel, please click on the like button and also subscribe. Do not forget to subscribe, just click on the subscribe button so that you will get daily updates from our side. So thank you for watching.